Equilibrium can be classified into two: static equilibrium and kinetic equilibrium. Yes, there are two types: static equilibrium and the kinetic equilibrium. Now, static equilibrium is basically very important to understand here. Why should we basically understand this? Why is it very important? We'll go through each and every one of them, but first of all, we'll understand what exactly the static equilibrium is. Here in static equilibrium, no reaction exactly takes place. So, yes, there is not much of, a probability of saying that yes, there is a reaction taking place. The reactants or concentration will be the same, products concentration won't be there. So therefore, since there is no rate of reaction or no net rate of reaction, then we can say yeah, the equilibrium is there. But this kind of equilibrium is static equilibrium because nothing much is going on here. If there's some kind of action going on, but then the net rate of the reaction is still zero, then we'll call this as kinetic equilibrium. In this, the reaction here takes place, but the reaction that will be taking place will be a reversible reaction. Okay, so it's going to be a reversible reaction, and in this one we will understand how is it reversible. We'll understand through the whole mechanics. Okay, so we're gonna do it now. Reversible reaction is very important to understand, going through each and every one of them, getting the idea of yes, this is happening and this is not happening. So first of all, let's say, oh yeah, this is known as dynamic, by the way, my bad. It's a kinetic, but then it's dynamic because there is cause too. Equilibrium should also have a cause, that's why we're including dynamic equilibrium. This reaction will be reversible, and therefore they will be denoted by a reversible sign, where the reactant gets converted into products and products being converted into reactants. Yep, here we have it. Okay. Now, reversible reactions are very important to understand. They are very important. Like, we need to get an idea based on what we are gonna do next. So, let's just mention the reversible reaction. Alright, so reversible reactions. Well, first of all, let's go through the reaction. The dynamic equilibrium. Okay, so there are three types of dynamic equilibrium. The first one is known as physical equilibrium, which we are going to study. Second one is known as chemical equilibrium, which we are going to understand. And the third kind of equilibrium, what is the third kind of equilibrium? The third kind of equilibrium is basically known as the ionic equilibrium. Alright, let's go to this side just to make it much better in the angle of perspective. So, yep, third angle of here and bam. That's how we are actually acing our streams. Okay. Let's go. Alright. Anyways, I don't know why I go to deep thinking. Never mind. Let's not say that. So yes, oh hi there. Okay, so there is a deep thinking. We need to have an idea based on that, and then we have equilibrium that is going on here. What is that equilibrium? What exactly is going on into that equilibrium? Let's understand one by one about that equilibrium. So EQM is the representation of the equilibrium. Equilibrium is also given in other terms. Okay, so we're gonna understand them each by each, one by one, and easy, nicely. So equilibrium is very important to note. It's very important to guess it out, and many ways. Okay, very ways. All right, that was very weird. So let's start off now. Equilibrium, dynamic, the concentration of the reactants, yeah, they can get converted into concentration of products, but again, concentration of products gets converted into concentration of reactants, meaning that the concentration of reactants and products is remaining constant, such that the rate of forward reaction is equal to the rate of backward reaction. So there are many of them, and we're gonna go each of them. But let's first of all learn physical equilibrium. So we're going to understand the physical equilibrium. Physical equilibrium. What is going to be the basic of physical equilibrium? What exactly are we understanding in physical equilibrium? In order to go through that physical equilibrium, let's just talk about water. Water. I don't have water right now, but once we take the solid of H2O, then could convert into a liquid form of water. That is, of course, H2O, that is ice being converted into water, and that is the solidifying part. Ice being converted into water, solid into liquid. Nice. We got it, okay? We are getting it nicely and correctly, and it's a very great method. Wait a minute, guys, I got to know one thing. Just wait a minute. Oh, yo, let's go. You're gonna understand this part, so wait a minute. Okay. Let's switch this on. Oh shoot, that was gonna reveal almost everything, but did not reveal it. Oh yeah. Litty, yo. Litty, yo. Yo, let's go. Uh, okay. I'm going to live. Wait a minute. Here was finite, huh? It's finite. Yo. Hey, bro. I'm studying equilibrium chemistry. H2O solid being converted into H2O liquid. Now H2O solid. Wait a minute. All right, let's go. Let's go. This is working nicely and great. But the problem is meat or J. Meat or J. Need. Okay. You know what's the idea. You know it. Physical process equilibrium. Solid to liquid. Suppose I do not have ice. I need to get ice. I don't have it. If I have it, then I would have got water. Okay, I'm so stupid. Anyways, yo, have some self-respect. I'm having some self-respect. I know what's going on in that camp. Okay. Yep. Okay, never mind. Sphanite. Yes, I will. You know what? You know the idea. You know the answer. Okay, I like maths. Maths better? Yeah, it's fine. I like maths. I do not go against that opinion, my boy. I like it. Maths is great. If you want, you can say maths is better than physics, chemistry, biology. I'll still be satisfied. That's fine. I'm not gonna be angry, man. I don't like going, back and forth. Oh, from the word of back and forth, we understand backward reactions and forward reactions, which are basically a part of chemical equilibrium. Now, suppose, let's understand this through an example, okay? Suppose there is a person who does not revise at all. He doesn't revise anything. He is just like, studying continuously, but he ain't revising. He knows the new topics, but he forgets the old topics. Like, bro, if you're studying the new topics, it's fine, but if you don't revise the old topics, you're just forgetting them. Meaning that he's maintaining equilibrium. Equilibrium is just one of the perfect examples that takes place in our life. What does the series 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 converts to? Alright, I gotta use that to solve it. Alright, just wait a minute. That is very interesting now. Huh? R as 1 by 2, A as this 1, converts to. Alright, okay. Okay, wait, is this an infinite series? Just tell me. Just tell me if this is an infinite series. Because I feel like, yes, it is an infinite series. Is this an infinite series? Yo, I'm accidentally using mathematics in chemistry. What the hell? Yo, I'm studying chemistry and you gave me mathematics. What? Oh, sure. You know what, Spadite? I will show you something which you really hate. Just wait for a minute, okay? I'm gonna show you something which you really hate. Okay, just wait, Spadite. Oh, this is gonna be very utterly weird. Yes. But yeah, remember that I'm your fan. Yes, okay. By the way, just tell me if this is an infinite series, because I feel like, yes, this is an infinite series. If I get this as a by 1 minus r, okay. Okay. Mm-hmm. This is the one. 2 minus, wait, okay, 1 by 2, okay. Alright, we have 2 viewers watching. Oh, wait a minute, let me just check my live, okay? Let me just check my live. Is it working nicely? What is going on here, dude? Yo, what the hell, man? Okay, I think it's an infinite series. That's what I know. Just wait for a minute and I'll give you the answer, okay? I'm still solving it. It's very easy, I know, that's for sure. That is GP. I know that. I know that's GP. And yeah, US fan, look at this, man. You got something very, a kind of sub begging which you really hate. Just wait a minute if I, just to check, okay? Oh my god, bro! Just consumer's equilibrium or producer's equilibrium? I'll go with no, 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 it's not economics, dude, it's chemistry equilibrium. There are many equilibriums that exist in our life. I'm not talking about that. Wait a minute, let me just check my live, dude. And then I'll give you the answer too, because I still have to solve a bit, but yeah, I'm almost gonna do it. It's an easy question, I know what you're trying to say. Just wait a minute. Because I feel like my voice is lagging. Yeah, yeah, that's what I'm saying. Just wait, wait. I have to first check my live. I'm still doing it. If you want, you can check it out. Here. Still, I'm doing, okay? Wait. Wait, just wait a minute. I feel like my cam is lagging. Wait a minute. I have to check my stream again and again and again and again and again and again and again. So, yeah. Bro! Oh my god, this is so utterly weird. Oh, no! Yeah, I know, but I have to check it again and 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 again. A cyclic process. You know what cyclic photophosphorylation? If you don't know, it's fine because you're a commerce student. That's what I know. Wait a minute. Totality. Yo. I see that. Okay. Wait a minute. Here we go. My live. And we go here. Let's check it. Okay. Let's see. Looks like rotational motion mentioned. GOAT. This message is held for review. What? Yep, okay. Oh yeah, you were saying this right? Let me calculate it. Wait a minute. Wait a minute, it's finite. Wait a minute, it's finite. So since this is an infinite series, I get the answer as 2. Okay, since it is an infinite series. The question I got, you're saying that 1 by 2 plus 1, say 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 dot dot dot. It's an infinite series. So I got the answer as 2, okay? That's what I'm saying. I got the answer as 2, okay? Because you did not give me the point or the nth term, that's why. And please wait a minute, I gotta study chemistry, not mathematics. Even though I like mathematics, doesn't mean that I gotta go through the whole thing, man. W is finite, though. W is finite. Go. Yeah, I like rotational motion. You study moment of inertia, you study angular momentum, you study angular acceleration, angular velocity. Then you study about radius of gyration, many stuff. It's really interesting. It's really good. I like it. It's also very much related to circular motion that you study, uniform circular motion. But there is a difference because in circular motion there is a point object which has its Okay, what is the locomotion of oxygen? You mean the movement of the oxygen? Bro, entropy, randomness. It could be very high. It could be maximum. But yes, again, I'm not sure whether I've studied that anywhere here, but I feel like I can say there is a high entropy. You know what's entropy? State of randomness or more disorderedness. Yep, that's what I can say. That's what I know overall. Okay, never mind. Solid gas equilibrium. Can I know in which class are you in? Looking like a class 12 boy who has studied from YouTube. Bro, SHSJ09 has literally got an accurate prediction, but there's one mistake. I'm actually a class 11th boy, a science student. Yes, bro, how did you get to know that I study from YouTube? Oh, shoot. Oh, okay, maybe, yeah. I think because I'm a YouTuber. My bad. My bad. Oh, man, I'm so stupid sometimes, I don't know why. Bro, have some self respect. Oh, yeah, my bad. My bad's finite. Oh shoot, I'm overreacting. Solid to gas equilibrium. Let's have camphor balls. Okay, camphor balls. Let's say this is rubber, but then that's not camphor. Now the camphor, when I keep it in its place, suppose here. Also, see, I'ma do some random BS. What is BS actually? What do you mean by BS? Yeah, and bye, bro. If you wanna go, I have no idea what's BS. Is it Brawl Stars or something? Business studies could be. Oh yeah. Man, I usually get confused with business studies and Brawl Stars. Oh. Oh yeah. I usually get confused. Now solid gas equilibrium. Camphor gets converted in the form of gaseous state, meaning that camphor of solid state reversible reaction. I'm 23 years old. I can tell your face, language, and energy because I have been through all phases and seen many. Oh, okay, sir. I see you, sir. Respect to you, man. Respect to you. I give you, sir. Thank you very much. Thank you. Yes. Looks like we are doing great. Okay, we're doing great here. And also, this is kind of very weird because you're saying that I have studied through YouTube, and you said you have gone through many phases. So, did you study from PW? Physics wala? I'm not sure. Could be. Could be. I don't know. You look like you're gonna say something which is basically like studying through YouTube. Yep. Point. Obviously. Alak Pandey. Bro has studied from Alak Pandey. That's what I can say for sure now. Is it? Is it? I have no idea. I'm just saying it. Hmm? I'm just saying it. Bro, even though you're saying obviously I have no idea. I'm just guessing out because that's the highest way I can get the prediction correct. So yes, but still I can understand you, sir. I salute you. You're one of those OG people I know. Nice. Equilibrium involving dissolution now. Equilibrium involving dissolution, that is dissolving, getting converted to this. Are you from India? English is crazy, man. Yeah? Uh, yeah, I know. I just want to have my targeted audience all around the world, not just Indian people. But yes, I'm actually from India, but again, I live in Gulf. I do not live in India. I'm not in India actually. I'm an Indian, but I live in a Gulf country. So yes, that's one thing you should know actually. In equilibrium involving the dissolution, that a solid gets converted into liquid, and that is here to here, right? Yep. So wait a minute, solid and liquid. Oh, sugar solid, then gets converted into sugar aqueous solution. So what I can say here is the sugar. Oh wait, I forgot there is another live going on. Oh shit. Oh, okay, here we go. And my cam is stuck. Nice. Sugar, solid, getting converted into a solution. Kind of interesting to know that. Aqueous solution. Now, okay, next thing here is gases in liquid. Gases in a liquid. Alright, we get CO2 and getting converted into what? Gaseous to a liquid state. What? Okay, this is interesting. CO2 gaseous to CO2 in liquid state. Now, let's understand this one by one. We have gaseous state of CO2 and the liquid state of CO2. Yes, we really do have one. Oh, well, let's go. I have a respect for those people who are OG, man. That's great. That is great. That is great. Okay. Let's go. Okay, 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 okay. It says that to watching is the thing that says it. Oh my god, this is very interesting. You wanna let me speak in English? Indian English? Alright. Look up Indian English. Hello sir, what to do? This is me. Totality Hayo. Okay. I'm I'm Indian, but also I live in Gulf. Just kidding. I can speak normal English. I'm just kidding, boy. Bro skipped. Oh sure, he skipped. Okay. Robert W. Let's see if he is live. I don't think so. He's most probably live, but he might watch my going on. Oh, bro, what is going on here? Click, clink, clink, clank, clink, 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 clank, clank. Yep. Yep. Let's go. You're doing it. 74. My laptop cam is stuck, dude. What, bro? What? Like, what is going on? My laptop cam is stuck. Yeah. I'm sick of this. Let's just report. Let's repair it. DVD. Oh, yo, hi there. How are you doing? This is me going to this. Then, BAM! No, what? No, dude. Got stuck. Let's go. There are two lives going on, huh? Now, CO2 gaseous converted into CO2 liquid. That is what is going on here. So, CO2 gaseous to converting into CO2 liquid. That is interesting, by the way. So solubility of the gas increases by the pressure of gas, and that is known as Henry's law. Solubility of gas increases the pressure of gas, making the concentration a bit more, actually, not gonna lie. If this gas is soluble, if it is like directly getting into the questions. Yep. Soda water bottle is sealed under pressure. Why is it so? See, if this is sealed under the pressure, it increases the solubility of the water having carbon dioxide, meaning that the carbonated water will be there. Yes, carbonated water is going to be present, and therefore we have the carbonated water. Okay, that is, let's say you want Coca-Cola, Pepsi, or that was I'm not gonna drink those, but yes, Coca-Cola, Pepsi, those have, there will be pressure inside them. Now this pressure inside them, you can see, is actually very interesting to note it down. The pressure is max, where since the pressure being max, the solubility of the gas is also increased because it's following Henry's law. So we can say that if the solubility of gas is increased, our pressure of gas will be increased, showing the proportionality sign, and therefore we get the idea of, yes, that's how it's happening and that's how it's going. Yep, that's how we get an idea based on that now. Alright, alright, alright. Now, what is the next one? Okay. So P is directly proportional to the partial pressure, is directly proportional, what we can say, is to the mole fraction of the gas. Mole fraction, that is chi. Chi. Okay, then that's not the chi you're thinking about. No, it's X actually, what's known as chi. That is the mole fraction. Okay, this is very boring content. I swear I make very boring content, but trust me, I can do it better. Yeah. Chi. Then we got partial pressure. Now, what is partial pressure? The pressure of that specific substance is known as partial pressure. Yes, the specific pressure, or the specific substance pressure is known as partial pressure, and therefore we get the partial pressure of a gas being directly proportional to the mole fraction of a gas. That's how it is increasing actually. Now let's basically understand another fact. Oh yeah, I forgot that there's a lot going on here too. Now, soda water when left in air turns flat. Why does it? So why is it basically turning flat? Like, what is going on? We need to understand that too. So first of all, what we're gonna do is that we need to write the Henry's law. So let's write Henry's law. Let's practice it. So the law states that uh, the partial pressure of a substance, pressure of a substance is directly proportional to mm, is directly proportional to the mole fraction of a substance. Actually, it's a gaseous substance, by the way. Gaseous substance. Yes, mole fraction of the gaseous substance. Yep, fraction of gas. Or yeah, in solution. In solution. In vapor phase. Of the gas in vapor phase. That's very weird to say gas being vapor phase. Huh? Okay. You know what? Let's just write this again. It's fine. You can do it. Oh man, I had to end the stream now. Like literally, I should do that. Like, dude, what the hell is this? Oh, that's messed up. Oh, that is messed up. Oh, oh, my charge is getting so low. I have no? But it's fine. I will be still streaming through this. Yep. Okay, bro. Like, why am I doing this so bad? Like, what is going on? Let's just check this out. Let's just check it out. Got this. DV20 camera, and here we go. Like, bro, what's going on? I still do not understand. What? Alright, let's go. Finally, it's working. Yep, here we go. Here we go! The law states that the partial pressure of a substance, the partial pressure of a substance is directly proportional mm, to the mole fraction mole fraction. Okay, you know what? Of a gas and vapor phase. That's what it says. To the mole fraction of gas in solution. Of gas in solution. Solution. Alright. Oh, yep. 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 Equilibrium in a chemical process. So soda water can is sealed under pressure of gas when it's hmm, ये बरोबर नीट लोक काही पैसा नाही रखा था निफम ये नहीं यार ये सब ये इन्फॉर्म ऐसा नहीं कोने में रखा क्यों कैसा आ गया ये Darkus. भाई हाँ रखा था पुश करके ये कैसा आ गया ये I don't know. Anyways, let's go. We're gonna understand this. So first of all, we got the partial pressure of a gas being directly proportional to the mole fraction of a gas in the solution. Yes, we got this. We got this. All right. All right. All right. All right. All right. Oh boy. Oh wait. Let's go. Equilibrium in a chemical substance. I think my phone is gonna go dead soon. Equilibrium in a chemical substance. That's I mean, go. Uh, pressure or solubility. Okay, here we go. The chemical process. Solubility of gas in liquid decreases with increase in temperature, though. So solubility of a gas increases or decreases when temperature. How? With temperature increase. Alright, we got it. Okay, equilibrium in a chemical process. Yep, guys, looks like it's coming to an end, but don't worry, I'm still gonna continue. Equilibrium in a chemical process. Okay, we aren't giving up. Let's say that there is a chemical substance A reacting with chemical substance B to give a chemical substance C and D. But this is also another thing that this chemical substance C and D again can react from a chemical A and B. So in the beginning, concentration of A and D are maximum, and hence rate of forward reaction will be max. Or so yeah, that's the one idea. Then okay. Oh shoot. Oh. Oh shoot. Oh, that hurts. Oh, that hurts. Oh shoot, that hurts. Yo, that hurts. Oh shoot. No, I'm never gonna touch that. Yo, veins are veins. It's fine. Can block that, but then, dude, that kind of hurts. Arteries. Yep. Wait a minute. Our arteries. Location of arteries.
definitely keeping used to so far. Like if I had to.
In brain. Sorry, in elbow.
Oh my
Yes.
god.
Elbow joint. Okay. That's great. Oh shoot, that hurts so bad. Like, dude.
Stop. No, I love.
Cubital fossa.
Okay, normally I don't like talking like this.
Oh.
Normally I stutter. Glad I like you. This is also the one that I wanted. She was so cute. Okay. You know what? I like you. This one's definitely the first. I love her
Let's not touch that.
so much. Second.
Right.
Wait, okay, you're third. These are my top three.
Okay.
Okay.
Let's go.
Third.
We can do it.
Fourth.
A plus B reacts with C plus D.
Fifth.
Loading this.
7, 8. Yeah. Definitely. I love her so much. Like, this is my style.
Okay, rate of backward reaction increases due to increase in concentration of C and D. When the rate of forward reaction and backward reaction becomes equal, the system attains equilibrium. That is the state of an equilibrium. Oh, the graphs of equilibrium. How can we forget that? So, we need to have an idea based on this. So, what is the exact graph of an equilibrium? That there is a time where the reactance concentration and the concentration of this product gets combined together, and this gives you the equilibrium concentration. This is throughout the time, and this is your reactant concentration, and this is your product concentration. Product concentration, giving us a basic idea, or we can say rate. It's not a matter of saying that time or rate. Then there is another graph where you can actually justify that concentration is equal. Suppose we can say that reactants are being here and product here, that is A plus B. Forward reactions require C plus D. Reactant here, and yes, reactants coming here, and then there is products here. That's, you can say, and then overall this is the rate. Okay, equilibrium equation. Okay, now this is very important. We're coming something to very important, that is known as law of mass action. Then how long is this chemical equilibrium? Let's have first. Okay, yes, it's a bit time taking, but don't worry, you can still do it. Still a bit time taking, but yep, you can do it. Yes. Okay. Many numericals. Oh wait, okay, we reached a point where it gets. Where is it? Ionic. What? Yep. Okay. All right. Looks like I will be charging this phone, so I will be going live through another device after dinner, but I will be still live here, so don't worry. Okay. So yep. Bye for now. For this stream, I'll still continue. What is going on here? What is this? Mirror side sibling. What is? Okay, what is code in that? Still do not understand. Okay. I did not turn into a skeleton. Should I remove this? And did I turn into a skeleton? Oh, I did not. Kaleidoscope. Here we go. Yep. Man, I did not like this because it's very trippy. It is very trippy. Hey, Weaver. That is very weird. That is very weird. This should be a thumbnail. This should be a thumbnail. Big head, yep. Still remember this. This one is really good. I got actually that problem for this one. You know what? Let's not use that. Yep, no effects. Yep.
Are they so full?
Looks like I'll be ending the stream through this one, and then I'm gonna continue through this device. Okay.
Wait, actually.
Right.
I like you here. This one's first, second. You know what? Third. No, actually, you know what? Third. The more that I looked at her,